Hello friends, my name is Dhyan Rathod and in this video I am going to present a short PowerPoint presentation on Intelligent Remote Implementation System IRIS, which is given as an assignment task by our faculty mentor Dr. Pawan Gupta. In this video I have chose this topic as I find it quite challenging and interesting in the field of well test analysis. So hope you like this video and let's begin with our presentation. From this video, we are going to know why we use IRIS, what is IRIS and how does IRIS works. So first we will see why we need to use IRIS. As we know that with increasing depth, the heterogeneity and complexity of reservoir data also increases. Thus, to know and analyze each and every parameter, we need to use sophisticated equipment. IRIS is very sophisticated equipment. It can record wide range of data. To supply power to drill string, we use IRIS. It allows power to transmit and can supply it to other drilling equipments. Also, the pressure pulses coming from subsurface are very complex. So, IRIS can easily differentiate it and can detect pressure pulses of wide range. As we know that to operate a DST tool, we need to apply annular pressure so that the valves can open and pressure data can be recorded. For example, to open a single shot reverse valve, pressure of 2000 to 3000 psi above hydrostatic pressure is to be applied. This can even collapse the tubing and casing. So, to overcome this type of problem, we use IRIS. Now we will see what is IRIS. The main thing here to know is that IRIS is not a separate tool, but it is used as a conjunction with DST tool, and it is the advanced version of DST tool. Since in DST tool, annular pressure is used to operate valves, but in IRIS it needs both annular pressure as well as battery power. In IRIS, it gives independent command to testing valve and circulating valve. And in this tool, both valves are capable to downhole pressure and temperature fluctuations for highly reliable performance. Now let's see about how IRIS work. The working of IRIS tool is like, first of all, low intensity coded pulses of at least 250 psi are sent down the annulus using the rig mud pumps. Then a microprocessor detects the pulses and compares them to preset operating instructions. After that, it opens or closes solenoid valves to direct hydraulic fluid from chambers at annular hydrostatic pressure into chambers at atmospheric pressure. Thus, due to this, the large pressure which is applied in DST can be avoided, and thus the tubing and casing collapse can be prevented. This fluid movement is used to operate the tool's valve, closing them with a high intensity force driven by a differential pressure rather than by just the force of a spring, which is in the case of conventional systems. This is how the IRIS tool looks like. As I said in my previous slides that it is used as conjunction with DST tool. We can also see that there is presence of batteries and other electronic sensors. Thus, each and every data can be recorded very precisely and accurately. This helps IRIS to be very sophisticated if it is used along with DST tool. Now let us see in graphical way the working of IRIS tool. Here the blue line indicates the TCP gun which is fired using annular pressure and the red line indicates the TCP gun which is fired using drop bar. The TCP gun means the tubing conveyed perforation gun and drop bar is a heavy steel bar which is dropped through tubing to fire the detonator on TCP assembly. First of all, small annular pressure is applied as we have discussed in the working of the tool. This will continue till the tool reaches the operating conditions. As the tool reaches the operating conditions, TCP gun is fired either by drop bar or by annular pressure. If the TCP gun is fired using annular pressure, there will be rise in the annular pressure as we can see in the figure. as TCP requires large pressure to fire the detonator. But if drop bar is used, it is dropped from high potential. Thus, TCP can fire the detonator spontaneously. Thus, the change in the annular pressure will be minimal. After the detonation of the tube, the flows are taken and the pressure data are recorded. And after the completion of the flow, the test valve closes with the help of battery and other electronic equipments. Simultaneously, the circulating valve opens and the tool can be retrieved. Now let us see some advantages of IRIS tool. The first advantage of IRIS tool is that it is very compact. As we can see that the 20 feet IRIS dual valve replaces conventional full wellbore test strings which can measure up to 40 feet. Thus, the length of the tool can be decreased by half. The other advantage of this tool is that it eliminates the pressurized nitrogen chambers and enhances the safety aspect of the tool. As we can see that in this the valve is operated with the help of battery and electronic equipments but not the pressure. Thus it becomes a very safe way to use this tool. The third advantage is the equipment is compatible with conventional pressure operated test equipment including the TCP systems. And the last advantage is it minimizes operating time by using automatic valve sequence commands. This was a short presentation by me, and I hope you came to know something about IRIS. Thank you.